We live in an incredible solar system with 8 fascinating planets, each with its own unique characteristics and traits. All these planets orbit around our magnificent sun, which provides us with light and warmth that makes life possible on Earth. But what else can you tell about our planetary neighbors? Let's find out more in today's episode of How the Universe Works. How did our solar system come to be? It all started billions of years ago when huge clouds of gas and dust came together. Gravity caused the particles within the cloud to clump together. As the clumps grew, so did their gravitational pull. Eventually, the center of the cloud became so dense that nuclear fusion ignited, giving birth to the sun. Meanwhile, the leftover gas and dust swirled around the newborn star and began to clump together, forming the planets. The planets are much like the sun. Each one is mostly made up of hydrogen and helium, but as they grew, they captured other materials, creating a variety of worlds. Mercury is the smallest planet, and it's also the closest to the sun, despite its proximity to the star. Mercury is not unbearably hot. Its lack of atmosphere means that there's no mechanism to retain heat, so it experiences extreme temperature variations between day and night. During the day, temperatures can reach 427 degrees Celsius. At night, they plummet to negative 180 degrees Celsius. Mercury has a very thin layer of atmosphere known as an exosphere. Mercury also has a magnetic field, although it's not as strong as Earth's. The source of this magnetic field is not a rotating liquid core as on Earth, but a partially molten core with a solidified outer layer. Venus is Earth's neighbor and almost twin in size. However, similarities between the two end at their size. Venus has a thick atmosphere made mostly of carbon dioxide. This creates a runaway greenhouse effect, trapping heat and making Venus the hottest planet in the solar system with an average surface temperature of 375 degrees Celsius. The atmospheric pressure on Venus is 92 times that of Earth. That's equivalent to being 900 meters or 3,000 feet under the ocean. These conditions make Venus an inhospitable place for life as we know it. Despite its harsh environment, Venus still has some intriguing features. For example, it rotates clockwise, opposite to most planets in the solar system, including Earth. Scientists think something massive must have crashed into Venus in the past. Also, Venus has no global magnetic field, but it does have a thin induced magnetosphere. This is created by the interaction between Venus's atmosphere and the solar wind. Earth is the only planet we know of that is habitable. It's the perfect distance from the sun, has a protective atmosphere and abundant water. These conditions make Earth unique in our solar system, at least for now. The atmosphere is mostly nitrogen and oxygen, which is a result of billions of years of evolution. It also has a protective ozone layer that shields us from harmful ultraviolet radiation from the sun. The Earth's core is mostly iron and nickel. This creates a magnetic field that extends thousands of kilometers into space. This field protects us from the solar wind, which is a stream of charged particles from the sun. Earth has many fascinating features, including its vast oceans, diverse ecosystems, and complex geology. There's still much we don't know about our planet, but scientists are continually making new discoveries. Mars is the 4th planet from the sun, and it's often called the red planet due to its reddish appearance. This is caused by iron oxide or rust on its surface. Mars is smaller than Earth and has a thin atmosphere, which means that it can't retain heat. The average surface temperature is negative 63 degrees Celsius. Despite its cold climate, Mars has some intriguing features. For example, it has the tallest mountain in the solar system, Olympus Mons, which is 3 times the height of Mount Everest. Mars also has evidence of past liquid water on its surface, raising the possibility that the planet could have supported life. Scientists are currently exploring Mars to learn more about its history and search for signs of ancient life. Now let's move on to the gas giants. Jupiter is the 5th planet from the sun and is by far the largest planet in the solar system. It's so massive that Earth simply vanishes into its colossal depths. Jupiter is mostly made up of hydrogen and helium, similar to the sun. It also has a faint ring system and more than a dozen known moons. Jupiter's core is believed to be metallic hydrogen. This creates a powerful magnetic field that traps charged particles from the sun. This forms the largest radiation belt in the solar system, which poses a hazard to spacecraft. Despite the dangers, several spacecraft have explored Jupiter, including the Juno probe, which is currently orbiting the planet. Saturn is the 6th planet from the sun and is famous for its spectacular ring system. Saturn is also a gas giant, mostly made of hydrogen and helium. It has a much weaker magnetic field than Jupiter, but its rings are much more extensive. Saturn's rings are intermediate in complexity, halfway between the more extensive set around Jupiter and Neptune and the simpler rings found around Jupiter and Neptune. Like Jupiter, Saturn has a core of metallic hydrogen. Saturn also has more than a dozen known moons, including Titan, which is the only moon in the solar system with a substantial atmosphere. Saturn is a fascinating planet with many intriguing features. Its rings are among the most beautiful and complex in the solar system, and its moon Titan is a promising target for future exploration. Uranus is the 7th planet from the sun and is unique because it rotates on its side. Uranus is an ice giant, mostly made of water, methane, and ammonia. It has a faint ring system and 15 known moons. Uranus was discovered by William Herschel in 1781 and is the only planet in the solar system that is named after a human. Uranus has a weak magnetic field that doesn't extend far into space. Its core is thought to be a combination of ice and rock. Uranus has a number of unusual features, including its sideways rotation and its peculiar atmosphere. Its atmosphere has strong winds and unusual features such as bright bands and dark spots. Finally, we come to the last planet in the solar system, Neptune. Neptune is an ice giant like Uranus and is mostly made of water, methane, and ammonia. It has a faint ring system and 14 known moons. Neptune was discovered in 1846 and is the only planet in the solar system that was predicted mathematically before being observed. Neptune has a strong magnetic field that's tilted at an angle to its rotation axis. This creates a magnetic field that extends far beyond the planet's atmosphere. Neptune has a number of interesting features, including its blue color, which is due to the presence of methane in its atmosphere. Methane absorbs red and infrared light and reflects blue, giving the planet its beautiful iconic color. Neptune's atmosphere is also very dynamic with strong winds and storms. One of the most notable features of Neptune's atmosphere is the Great Dark Spot, which is a massive high-pressure storm. Our solar system is a vast and complex place. From the scorching Mercury to the icy Neptune, each planet is unique in its own way. As we continue to explore our solar system, we're sure to make even more amazing discoveries. Please continue with me. Our solar system is full of mysteries. Some are hiding in plain sight, like the fact that all of the planets' rotation axes are almost parallel to each other. Others are just waiting to be discovered, like how the heck anything can survive in the radiation belts of Jupiter. And some are so weird, they might make you question reality itself. Like this image taken by the Cassini spacecraft showing what looks like a smiling sun. So buckle up because we're about to take a tour of our cosmic neighborhood and uncover some of the secrets that lie within. Now let's start with a bang, or rather a boom. There have been several suspected booms heard on Mars, but it was only when researchers analyzed data from NASA's InSight lander that they realized some of these sounds were actually caused by falling rocks. The mystery remains as to why rocks are raining down on the red planet's surface. But hey, at least we now know that Martian booms aren't little green men bowling night. Okay, here's something really freaky. On Jupiter's moon Europa, there's a crack that stretches for thousands of kilometers. And according to scientists, it's not just one big crack. It's actually many small cracks bunched together. You know what's extra creepy? That this is happening on an icy moon that could have a whole ocean under its frozen crust. Scientists think the cracks are caused by tidal flexing from Jupiter's gravity. But if you ask me, this looks like the beginning of a very bad case of bedhead. Alright, it's time for a bathroom break. Let's head over to Saturn's largest moon, Titan, where it rains so much that there is a whole river system complete with lakes and even an ocean. Yeah, no joke. The moon Titan is the only place in the solar system outside Earth where there is confirmed evidence of surface liquid present. And it's not just regular old water. We're talking about ethane and methane rain. Think of it as your friendly neighborhood petroleum precipitation. And if you're curious about what's causing all this rainfall, here's your answer. Titan's atmosphere is thick, which means it traps heat and creates a greenhouse effect. Plus, the moon has a bunch of volcanoes spewing out all kinds of cool stuff, including water vapor. All of this adds up to a seriously toasty surface temperature of around 94 degrees Celsius. No wonder it's always raining on Titan. Just remember, if you ever visit, don't forget your umbrella. Okay, now let's talk about something that's really freaking cool. This weird-looking cloud formation was spotted on Jupiter, and it turns out that it's a totally legit storm that has been raging on the planet for years. Seriously, this thing is so massive that Earth just vanishes into its colossal depths. If that doesn't blow your mind enough, check out this crazy fact. Scientists predict that there are over 500,000 km high storms raging on Jupiter, which is enough to blow your mind. Jupiter has more than twice the mass of all the other planets in the solar system combined, so it's not surprising that the gas giant has some serious storm action going on. I mean, it's so massive that it generates its own magnetic field, which is like 1,000,000 times stronger than Earth's. That's enough to whip up some seriously epic storms that can last for centuries. So while you might want to stay away from Jupiter's colossal clouds, just remember that these storms are just part of what makes the planet so incredibly awesome. Alright, now let's take a trip over to the mysterious moon Enceladus, which is known for its dazzling display of geysers. These enigmatic eruptions shoot water high into space and have given scientists a unique opportunity to study the moon's interior without even drilling into the surface. According to some estimates, Enceladus could have a vast ocean of liquid water beneath its icy exterior. And if that's not enough to pique your interest, consider this. The moon might also have more than twice as many Earth-like volcanoes than any other place in the solar system. Talk about a hotspot. Imagine that. You're recruising along on a rocket ship when suddenly you hear a loud bang and feel a jolt of motion. What do? Well, first you check out the view from your portholes. Luckily for the crew of New Horizons, they witnessed something truly spectacular. The impact of a small object on the dwarf planet While such crashes might seem like a nuisance, they offer scientists a unique opportunity to study the composition of distant objects in our solar system. By analyzing the color and brightness of the plume created by the impact, astronomers can learn a lot about what Makemake is made of. So instead of panicking, they documented the event and sent the data back to Earth. Who knows, maybe one day they'll even find out what caused the crash. Until then, it's a reminder to always be prepared for the unexpected when exploring the great beyond. Alright, now let's talk about something that's really freaky. There's a giant cloud of alcohol floating around in space. I'm not talking about a spilled drink or a drunken astronaut. This is the real deal. A team of researchers found that there's enough ethanol in this cloud to fill 400 billion 200-ounce bottles. Now that's a lot of booze. But what's even weirder is how the alcohol got there. It turns out that the cloud is located near a young star called V649 Tauri, and it's made of organic molecules that are produced when UV rays hit a disk of dust surrounding the star. That's right, this interstellar alcohol is literally being brewed in space. So if you're feeling thirsty, just set your sights on a nearby star and you're in luck. Just kidding, don't try this at home. The alcohol in space isn't exactly drinkable. It's probably mixed with all kinds of dangerous stuff like hydrogen cyanide and carbon monoxide. Plus you'd need a pretty big spaceship to transport all that alcohol. But hey, who needs a drink on Earth when you can get one delivered straight from space? Okay, now let's turn our attention to something a little closer to home. The asteroid belt between Mars and Jupiter is full of weird and wonderful objects that are leftovers from the early days of the solar system. Now let's talk about something that's really bizarre. Scientists recently discovered a huge crater on Mercury, the smallest planet in the solar system. This crater, named Hokusai, is almost 700 kilometers wide and was likely caused by an asteroid impact in the past. But here's the kicker. The crater is surrounded by strange linear features that resemble spiderwebs. These wrinkles are actually compressional faults that formed as the planet's crust tried to shake off the impact. Now, here's the weird part. The age of the crater suggests that it's one of the youngest on Mercury's surface, meaning that Mercury is much more geologically active than we thought. It's like the planet is still shaking off the shock of the impact. So if you're anywhere near Mercury, watch out for flying spiders. Just kidding, but seriously, don't go anywhere near there. So there you have it, folks. From mysterious cracks on Europa to molecular cocktails in space, our solar system never ceases to amaze. Remember, every time you look up at the stars, you're seeing just a tiny slice of what's out there. And with every new discovery, we're uncovering more and more wonders of the cosmos. So keep looking up, because who knows what we might find next. This is a space engine. Well, it's more of a proof of concept right now, but this is what scientists hope will one day ferry people between planets in our own solar system. But before we can get there, there's a lot that we need to know about the places in between. This is the first in a series where we're going to explore the secrets of our solar system and how the universe works. And if you stick around until the end of the series, you will learn how studying the solar systems around us can help us answer some of the biggest questions in astrophysics. First up, let's talk about the outer edges of our planetary system. You may have heard of the asteroid belt, the region between Mars and Jupiter filled with rocky leftovers from the early days of the solar system. But beyond the asteroid belt lies an even more mysterious realm known as the Kuiper belt. The Kuiper belt is a vast, flat disk of icy objects orbiting the Sun, similar to the asteroid belt, but much colder. It begins at about Neptune's orbit and extends outward for almost 50 astronomical units, or 50 times the distance between the Earth and the Sun. That's far enough out that the Sun's warmth barely reaches these distant regions. So the objects in the Kuiper belt are mostly frozen solid. Like the asteroid belt, the Kuiper belt is made up of rocky leftovers from the formation of the solar system about 4.6 billion years ago. But unlike the asteroid belt, the Kuiper belt has stayed relatively unchanged over billions of years, because its objects are so far away from the Sun. And this means that the Kuiper belt is a kind of time capsule that can tell us things about the conditions in the solar system during its early days. In fact, many of the objects in the Kuiper belt are called KBOs, or Kuiper belt objects. As of 2023, we've only identified about 2,000 KBOs, and because they're so dim and difficult to observe, most of them are only a few miles across. But one famous exception is Eris, which is about 2,300 miles across, almost as wide as the United States. And the discovery of Eris was actually a big deal, because when it was found in 2005, it caused astronomers to rethink their definition of a planet, because Eris is almost exactly the same size and mass as Pluto, which had been considered the 9th planet since its discovery in 1930. Some astronomers argued that if Pluto wasn't a planet, then neither was Eris in 2006. The International Astronomical Union ultimately decided to reclassify both Pluto and Eris as dwarf planets. And today, Pluto is considered the most famous member of the Kuiper belt. But there is also another feature of the Kuiper belt that is even more mysterious than its dwarf planets, the scattered disk. The scattered disk is a grouping of Kuiper belt objects that have been knocked out of their original orbits by Neptune and now travel in highly elliptical paths that extend as far out as 100 astronomical units. The existence of the scattered disk suggests that Neptune, which orbits the Sun at just 30 astronomical units, once had an even more massive companion planet that was kicked out of the solar system long ago. But even though we have evidence of this ancient giant planet, we don't know what happened to it. One idea is that it was flung out of the solar system entirely, and is now wandering the universe as a rogue planet. Or perhaps it was captured by another star, or maybe it didn't exist at all. It could be that Neptune formed in its current location and used its immense gravity to carve a gap in the Kuiper belt and form the scattered disk. Either way, we're hoping that future missions to the Kuiper belt will help us solve this mystery. One such mission is NASA's upcoming Dragonfly spacecraft, which is scheduled to launch in the mid-2020s. Dragonfly will reach Pluto in 2037 and spend about 2.5 years exploring its surface and subsurface ocean. We'll also be launching an even more ambitious mission to the Kuiper belt, the New Horizons mission to Pluto, launched in 2006. New Horizons reached Pluto in 2015 and revealed a world full of diverse landscapes and surprising discoveries. But the mission isn't over yet. New Horizons is still operating and will make a close flyby of the Kuiper belt object Arakoth in 2024. This will be the first up-close look at a Kuiper belt object, and we're hoping to learn more about how worlds form in the outer solar system. So while the Kuiper belt is an important part of our solar system, it's not the outermost region. That title belongs to the Oort Cloud. The Oort Cloud is a theoretical sphere of icy objects that surrounds the solar system and extends as far out as 100,000 astronomical units. We don't have any direct observations of the Oort Cloud, but based on the paths of certain comets, we know that something interesting is happening out there. As I mentioned earlier, most of the objects in the Kuiper belt orbit the Sun in fairly predictable paths that are generally flat, but some Kuiper belt objects have highly eccentric orbits that bring them close to the Sun every few hundred years or so. For example, Comet Hyakutake, or the Great Comet of 1996, has an orbit that extends as far out as 3000 O before swooping close to the Sun every 300 years or so. And these strange orbits suggest that these objects were once trapped in the Oort Cloud and then got nudged into the inner solar system by some unknown force. But exactly what's out there is still a big mystery. Some scientists believe that the Oort Cloud is a giant sphere of icy bodies that surrounds the entire solar system like a protective bubble. Others think that it's more of a lopsided pancake that extends only a few thousand O from the center of the solar system. And still others believe that it's not a cloud at all, but a collection of many smaller groups of icy objects that were brought together by a giant molecular cloud that passed through the solar system long ago. Unfortunately, we won't have any answers to these questions anytime soon because the Oort Cloud is so far away that it would take Voyager 1, the most distant spacecraft we've ever launched, more than 300,000 years to reach it. So it seems like the outermost parts of our solar system will remain a mystery for now. Okay, so we know what's in the outer reaches of our solar system, but what about the inside? What happens between the Sun and the Earth? And how does that affect our lives here on the Earth? The interior of the solar system is dominated by the Sun, which makes up 99.8% of the mass of the entire solar system. The remaining 0.15% is made up of the 8 planets and their moons, with Earth being the 4th closest to the Sun. Each planet has its own unique characteristics, from the scorching hot Venus to the frigid, windy Jupiter. Earth is special because it's the only planet that we know of that has life. We're still searching for signs of life elsewhere in the universe, but until we find it, we are going to continue exploring our cosmic backyard to learn more about the conditions that make Earth so unique. In fact, we are already doing this with NASA's Parker Solar Probe launched in 2018. Its mission is to study the Sun and its effects on the solar system, including the space weather that can disrupt important things like our telecommunications and power grid system. But we're also learning about other potentially habitable worlds by exploring the atmospheres of planets and moons throughout the solar system. For example, the European Space Agency's upcoming JUICE mission will explore Jupiter's moon Europa, which has a subsurface ocean that could potentially harbor life. By measuring the composition of Europa's atmosphere, JUICE will help us better understand the conditions on the moon's surface and its potential habitability. We're even searching for signs of life in places you wouldn't expect, like Mars, which has an atmosphere that's much thinner than Earth's. NASA's Perseverance rover is exploring the surface of Mars and collecting samples of rock and soil that will eventually be returned to Earth for analysis. Perseverance is also carrying a small helicopter named Ingenuity, which is testing the possibility of flight on Mars. If Ingenuity is successful, it could revolutionize our ability to explore the red planet and search for signs of past or present life. But what if we find life elsewhere in the solar system? How should we deal with that? While scientists are already thinking about this, there are lots of ethical questions about what we should do if we find microbial life on a world like Europa, especially since we don't want to contaminate other worlds with bacteria from Earth. That's why NASA has developed strict guidelines for planetary protection that must be followed by all spacecraft that explore potentially habitable worlds. But if we were to find intelligent alien life, like a civilization capable of building spaceships, then we'd have to think about how to make first contact. Scientists have come up with a variety of ways to safely approach an alien ship, including using robotic probes to communicate and survey the ship from a distance. We'd want to learn as much as possible about the alien technology before making any direct contact. Of course, we'd also want to be prepared to defend ourselves in case the aliens were hostile. But hopefully it wouldn't come to that. If we could establish peaceful contact with an alien civilization, it would be one of the most exciting discoveries in human history. But whether we find little green men or not, we're going to continue exploring our solar system and searching for answers to some of the biggest questions in science. And it all starts with understanding our place in the universe. This is the last episode in our series, and I hope you learned something new and exciting about the universe and our place in it. Remember that everything we see around us, including the stars in the sky and the planets in the solar system, is made of the same stuff, the same atoms and molecules. And that means that the laws of physics work the same everywhere in the universe. That's why studying the solar systems around us is so important. By observing other systems, we can learn more about how our own solar system formed and evolved, and we can also use other systems to test our theories about how the universe works. In fact, astronomers have already used other solar systems to make some amazing discoveries. For example, by studying the atmospheres of planets outside the solar system, astronomers have found planets that could potentially have life. They've also discovered exoplanets that orbit more than one star, which is something that we don't see in our solar system. These discoveries have helped us better understand the diversity of worlds out there in the universe, and they've also challenged our ideas about what a solar system can be like. But the most exciting thing about exoplanets is that they could help us answer some of the biggest questions in astrophysics. For example, by studying the atmospheres of planets that orbit red dwarfs, astronomers hope to find the first signs of life outside the solar system. Red dwarfs are small, cool stars that are very common in the universe, but their strong flares and X-ray emissions can make it difficult for life to evolve. If we can find a planet that has life despite these challenges, it would tell us that life really can thrive in extreme environments. Exoplanets are also helping us test our theories about how solar systems form and evolve. For example, by studying the orbits of exoplanets, astronomers have found systems that have multiple planets that orbit very close to their stars. This is something that we do see in our solar system, and it challenges our ideas about how planets migrate and interact as a system evolves. In the future, exoplanets will play an even bigger role in our understanding of the universe. With the launch of NASA's James Webb Space Telescope, we'll be able to study the atmospheres of exoplanets in even greater detail, and the European Space Agency's upcoming LISA mission will search for planets that orbit to black holes, a phenomenon that we've never observed before. These discoveries will help us better understand the diversity of worlds in the universe, and they'll also help us answer some of the biggest questions in astrophysics.